In this session, we'll see, what are the various digit services and their respective Git repos, right? So in one of the previous videos, we saw, how digit services are, you know, uh, deployed and what are their different layers of digit services, right? So we saw core services, business services, and municipal services, and then front end and stuff like that, right? So today we'll see, what are their Git repos. So if anybody, since Digit being an open source, so if anybody wants to contribute or anybody wants to extend or like for the partner ecosystem, if they want to build on top of it, right? So where are the repos and how one would do it, right? So let's see the core services, which is nothing but the bottommost layer. So that actually lays the uh, um, the platform, right? So here is the repo. So GitHub egovernments is an organization and core services, right? So yes, so this is a Git repo, which is an open source project, that like, you know that uses the MIT license. And these are the various microservices in each folder. But again, core services is a monorepo, right? So a developer who wants to work on any specific service, for example eGov IDGen, he would rather sparse checkout, or he can check out the entire. If he is working across multiple, he can check out the entire monorepo and work uh, into a specific service, right? So each service is a small spring boot, the service, and this is how the repo is organized, right? So we will have code owner. So basically, you can decide who can be the reviewers and approvers of your, PR, right? So this is core service. Likewise, we have business service, municipal service, and then front end and stuff like that, right? So let's see what is there in the core services, right? So first of all, like let's see, um, when we say digit platform, right? How, I mean, what are the various services are there, and what category of services are they, and how do you actually step by step deploy services when you provision a Kubernetes cluster which is fresh, right? So which is generic. You can create a Kubernetes cluster on any commercial cloud like AKS, EKS, or GKE, or like on premises also. Let's say you have got plain VMs and then you need to provision a Kubernetes cluster. You can use kubeadmin or kubespray to basically create a Kubernetes cluster. And once you have your Kubernetes cluster, so how do you actually, what are those services that you would deploy step by step, right? And I mean, where are the respective repos, right? So first, let's see core services. So these are the core services that we saw under the repo, e-governance core services, right? So next is business services. We have billing, collections, dashboard, and voucher index, apportion, EDCR and finance. So these are the monolith application which is on a ERP, but again that is containerized and again deployed seamlessly on a Kubernetes cluster, right? So this is how the various the these are the various repos of these services, right? And we have egovernments-data. So this is nothing but master data management system. So predominantly it will have all the JSON files that supply various configurations for various services and in the UI, whatever the controls and stuff like that. And there is another repo called customization. So yeah, so core services, business municipal front end, MDMS, provides you the master data management. So how do you actually, you know, extend this? How do you, fork this, right? So let's look at an example. Okay, so anybody who wants to extend this repo, you can always fork this. So let's see how you can fork, right? So, you can choose your respective, whichever the, um, or you can directly go into your repo and, you can always search for like, e-governments. Yeah. So you can search, since it's a open source and publicly available, you can always fork it. And like, let's say I'm a new state, I just want to, fork this, and it can be, anything. Not necessarily it should be a state. You can be any open source community or a partner ecosystem or a state ecosystem. You know, anybody can fork it, and you can actually start, making changes. And when you feel that, you know, whenever there is a new version, you can always take a pull. And if you feel that there is a new service you have added, you can raise a PR, right? So that's how you can actually extend the repos. Likewise, it is not limited to only core service. You can do front end, municipal, business, and core services, right? So MDMS data is state specific or for any environment specific, right? So there is the basic template that you will have to fork and then put in your state specific data and stuff like that, right? Similarly, the customization, so which is again like uh, you know you can look for. So for example, this is the internal, MDMS data, right? So the same thing should be forked. So MDMS data and customization, since it is environment specific, these are private repos. So you will get a template, like state MDMS data and state customization, right? So these are the template, right? So these are public, which you can again MIT license, which you can again fork and put in the data specific to, like for example the tenant, right? So you know it says like replace it with desired tenant, right? So if you are working for a specific state, like for example Tamil Nadu, right? So you can put the TN as a tenant. So likewise, you know the MDMS and config, so these are state specific or environment specific. This should always be forked from a template, and you would put in the state specific configuration, right? And there is a ERP stack as well, for example like EDCR or finance, so which is um, ERP based, which is a monolith application, which is a ERP again, right? So how does it look? So most of our, the ERP stack look like this. So there will be a load balancer and Redis for caching and user token management. And Wildfly is being used as a application server, and these are like horizontally scalable based on prod, UAT, and dev and stuff like that, right? And again, like Postgres is the database, and there is a file store used for storing any PDF files or images and stuff like that. So this file store can be varying from the you know based on the cloud. So if you are on a commercial cloud, it can be S3 or Azure Blob or things like that. Or if it is an SDC kind of thing, it could be an NFS or iSCSI volumes, or it could be a any file system as well, right? And Postgres, you can set it up separately, depending upon the usage. You can always set up slave and master, and then Elasticsearch that reads the data from slave and used for you know analytics, and then putting dashboards and stuff like that, right? So this is again like you can always containerize. So for example, you know so there is a EDCR, you know though it is a monolith application, right? So this is how you can containerize, right? So you can write a Docker file. There's a multi-stage Docker file. So first it just builds it, and then it'll be a fat instead of a jar. It'll be a EAR. It'll be comparatively large in size, but so based on that, you need to decide, what is your CPU and memory that you would allocate for your container to run, right? But it is very much possible to run an ERP system into a in a Docker, and which can be orchestrated again onto the Kubernetes cluster. So it can still stay with along with your microservices, and like interact with your microservices and stuff like that. Okay, so yes, and next is the CI/CD. So we do have like the repos for CI/CD. So for example, like you know So how the CI/CD happens, right? So these are individual microservices, probably different developer teams are working on it. So all they need to do is like, they just need to get into build, and there is a file called build config, right? So here is where, developers can just put in their, respective service detail. For example, like, uh, builds, then here is this is a folder structure I want to create in my Jenkins. So I want to create the folder called builds. Inside builds, I want to create a subcategory as core servers, and inside that I want to put my the job like egovernment master, right? So what is my working directory? How do I want to name my image? So this is basically your Docker image that comes out once you bake your image, right? And where is my Docker file? So Docker file, instead of, you know, creating Docker file separately, since all are, the Spring Boot based application, so you can keep it at one place, like, this is the Docker file. So every Spring Boot application follows the same standard and same pattern and stuff like that. So just depending upon the service, it always replaces its name. But otherwise, every Docker, Docker file for every service is predominantly the same, right? This way, you don't need to create multiple Docker files. So this gives a lot of advantage, like, if you want to upgrade your JDK, or like, you want to change the logic of it, so you can very well do that. And you can always customize these alpines based on your environment specific. Like, you can inject worlds, you can add like security, fixes and stuff like that. You can always customize it, and it's easy to enforce the standard, since this is being a single file for all the various services, right? So this is how the CI, the integration happens. A developer needs to put their respective code here, and and there is another, the Git repo called CIOps, which is an open source again, which anybody can fork it, and they can put in their respective details, like, so this is purely based on the Jenkins on a Kubernetes cluster again. So the advantage of it is, like, you can, if there is a, like, multi-branch pipelines, or like, multiple teams are seamlessly integrating their code, and if you want to have your Jenkins absolutely completely scaled and highly available, so you can deploy your Jenkins on a Kubernetes cluster, and then you can use Canico, which is a, you know the containers for building and baking and stuff like that, right? So that's exactly what our Jenkins does, and the CI ops is basically what you need to refer to leverage the existing CI/CD system, right? So for example, like, I want to create a build pipeline, right? So there is a GUI, that takes care of, like, that reads the data from your um, the build config dot YAML. So yeah, so it reads this particular, the file, it understands all this, and it creates the jobs automatically like this. If you can see, builds, and then inside the core servers, and then so it is completely automated. So you don't need to, manually create all this, right? So all you need to do is, you come here, just run this job builder. So job builder takes care of, it understanding, what are the various services, and based on that, it can create a Jenkins job, right? And at the same time, every job will follow the same standards, right? So it's not like it vary from service to service, right? So that way, again, like, you can maintain the standards and stuff like that. So across all these services, the CI and the Docker file and the way that you bake the image, everything is same. This way, it's very easy to enforce and maintain the standard, right? So this is again open source, so you can fork it and use it. And InfraOps is basically for all your, operations, like, from an environment to environment. How do you actually create your deployment manifest? So how do you maintain your, yeah, so InfraOps is basically, it allows you to create your deployment manifest to deploy on various Kubernetes clusters, and how do you Dockerize it and stuff like that, right? So for example, if you are using Helm-based deployment, so this is how you can keep various environments, and inside each environment you can put environment specific values. So these are the global values, and whatever the services that we have seen, like core services, so every services are put here, and whatever the values that you need to override, so you can always override from here. And the deployment again happens through um, you know I mean respective servers will read the respective Helm chart, and it'll look for values. Again, the values, you will have overrides coming from your deployment manifest. So things like that. So to manage all your, CI/CD, sorry, this is CD basically, deployments, and you know, create your Helm charts for your servers and stuff like that. So that is supplied by egovernments. So this is a private repo, but if you want to leverage this, you can always, uh, yeah, you can always take the template from train InfraOps, and you can similarly, add, or you want to customize things like that. You can very well do it. So this you can always fork it into your repo and work on it, right? So these are the various repos that you might have to know, if at all you're a partner ecosystem, or the open source community contributor, things like that, right? And what is a branching strategy to essentially continuously build and deploy? So yes, so this is the branching strategy. So I mean, there is a develop branch, and always there are a number of feature branches which can always, merge back to a develop. So develop is a continuous, the development branch, and each state will, and which again, like, every time when you release, you always, merge it back to master and create a tag, and from the tag, you would actually release it, right? And there will be a release branch. So how that happens, from a develop, after a code freeze, you would always branch out as a new release branch, and on a release branch, you would be working on the release readiness fixes, bug fixes, and stuff like that. So once the release is ready to be, you know uh, deployed across any specific environment, it will always go to master, and from master it will create a tag, and from the tag, you know, you will again create the containers with that tag, and you will deploy it across the target environment, right? And how does it happen in a states case, or for any partner case? So for example, PBBH, UK, or partner, right? So these can be, the forked repo. You can fork this repo into your um, respective, GitHub, and you can always take the, pull from any of these, the tags, and you can maintain your own tagging mechanism and stuff like that, right? And if at all there is an enhancement, or you want to contribute back, you can always raise a pull request to master, and that can come to master and gets cascaded into, the develop and the other feature branches. So this is the branching strategy and the tagging strategy, right? Yeah, so with this, we're concluding the walkthrough of various digit services and the Git repos, right? And one last thing, like, this is the sequence in which, the various services, that gets deployed when you have a fresh Kubernetes cluster, right? So we'll start off with the backbone, services, which are like, the stateful sets. For example, the Zookeeper, it'll have its own persistent volume claim and a persistent volume as well. So you need to provision a persistent volume for this depending upon your cloud infrastructure, whether it is commercial or on premises. It could be iSCSI or NFS in the on-premises case, or it could be, EBS volumes, or like, Azure Disk in the, commercial example, right? So these are some of the stateful sets um, that would be deployed first. And after that, like, Redis, that is to provide the, the caching and user, token management. And you will deploy Cert Manager for your SSL certificates and stuff like that. And the Nginx Ingress. Nginx Ingress, once you expose your Nginx Ingress, so you will get a load balancer depending upon the cloud infrastructure. If it is on premises, you will have to map this to a node port, which is a public IP, right? So then the public IP or a load balancer will be mapped to a DNS that has got the SSL provisioned by this cert manager, right? And then the Zool. So Zool again, that is for your authentication and authorization, right? And then you will start off with the bottommost layer in our architecture, which is core services. So this lays the platform, and then you will go with the business services. So it can be optional, not like, every state should choose all of them, depending upon what municipal services that they are opting for or that they want to customize on top of it. So depending upon that, the supplied business service and the core services would be deployed. And finally, the front end. And then there are additional, plugin services like, Kibana dashboards for your logs, both infra and, application logs, and for your telemetry and for your tracing, Jaeger, for your distributed tracing basically, and playground and PG admin. If in case, you need to give access to the database for the developers to, debug, so they can always, put forward or like, shell in exec into the playground pod and connect to the database and then, work on it. But this is not like for prod and UAT kind of environment. This is mostly like dev and QA, where your developers and QAs can get access and then they work on it. And the Kibana and Jaeger dashboard, it can use the, separate credentials, or you can always integrate with your GitHub teams and stuff like that, so that, it gives access to the various dashboards. So these are the step-by-step services that you would deploy. So these are the generic, the images. You don't have to, build it. For example, the gateway services and the backbone, it is like, you would directly get it from your, the container registry. But all this core services, business services, it should be from your own container registry that you actually build and deploy. Like, for example, you want to take it from the general, container registry, or you want to use the customized. So then you will rename it, according to your, the naming convention. You would push it, and then you would use that image to deploy, right? Yes, I hope, we have covered all of this, topics, and thanks for watching.